Okay, today we're going to look at the big idea of solving quadratic equations. Specifically, we want to look at solving algebraically, and we have four options. We could solve using square roots, solve by factoring, solve to find those x-intercepts by completing the square so that we can isolate that x. And then our fourth option is solve using the quadratic formula. Okay, just to give you an overview, this is the progression of what I would recommend for choosing your method. So I would choose to use square roots if two things were true. If I had a quadratic equation in standard form where my b is 0, I'd only have one x term, and so I could just solve for x. Using my order of operations in reverse, I'm undoing those operations so that I can solve. The other possibility is that you would have a quadratic equation already written in general form. And again, you only have one x variable. And so you would be able to isolate that. So notice in this example, there's only one x, and in this example, there's only one variable term. And so you would be able to ditch everything else and solve for that. Choice number 2 would be factoring. And there are two times that I would choose factoring. I would choose factoring if I had an equation in standard form where my c is 0, because at that point I get to skip straight ahead and look at my two terms and see what's common to both and choose that greatest common factor, and that will get me to intercept form immediately. I'll be staring at my roots. The other option is if we're in standard form, we have all three values a, b, and c. I would choose factoring if a times c, right? If I find there are factors of a times c that either add or subtract, whichever the case may be, to give me b. So if that is something that holds true, when I multiply a times c and I look for factors, I can actually find a combo that will either add or subtract to get me b, depending on my sign. Then I'd go ahead and factor. My third option would be to complete the square. And I don't mind completing the square one bit when a is 1. And I also don't mind completing the square when I start the process and I don't have any fractions or decimals to deal with. So specifically, we know if a is not 1, which is Algebra 2 style, then I would first choose to divide my quadratic and linear terms by a so that I could reduce to just focus on building one square. And when I do that, I'm going to end up with b divided by a, that linear term. The coefficient of the linear term tells me how I need to find the dimensions of my square. And as long as I don't have fractions or decimals there, so if b over a is an even number as your result, then I'd complete the square. Otherwise, I'd move right along to option number 4. That's kind of my last resort because I would use quadratic formula when all of my other options fail. Okay, so let's look at some examples, and we'll just kind of go through the thought process for these 8 quadratic equations. What options do we want to use? What's the most efficient method? I mean, we could use quadratic formula every single time, but that's going to be more cumbersome than what's necessary in some conditions. It just depends on the characteristics of your quadratic equation. Okay, so let's go ahead and get started. Let's roll through our progression with negative 3x squared minus 6x minus 5 equals 0. Okay, so the first question is, can I use square roots? Do I only have one variable term? Nope, that's out because I see x squared and x. So we move on to factoring. Do I have a standard form where my c is 0? Nope, not here because my c is negative 5. So then I would check to see, well, since I do have ax squared plus bx plus c, what is a times c? Negative 3 times negative 5 is a positive 15. Are there factors of 15 that will add, since it was positive, factors of 15 that will add to give me 6? 1 and 15, 3 and 5. Those won't add to give me 6. So I move on to option number 3, which is completing the square. And I know that I'm going to divide by my a if I'm completing the square. So the question is, when I divide by that negative 3, is my b over a going to be beautiful? No fractions, no decimals. Life is staying pretty simple. And in this case, it is, because it'd be a positive 2. So for that reason, I would choose to stop there and just go ahead and complete the square. Okay, let's try the next one. Looking at negative x minus 2 squared plus 1 equals 0. First option is square roots. Do I have just one variable? Yes, I do. The only variable, since I'm in general form, is the x inside of my parentheses. And so for that reason, I'd start ditching. I'd use my order of operations in reverse so that I can solve and undo all of the things that have happened to x. So I would choose to put that one under square roots. Okay, next one. Negative 2x squared plus 5x minus 1 equals 0. I see all three terms, quadratic, linear, and my constant. So automatically I'm skipping over square roots because I'm not in general form and I do have a b. Okay, so I'm going to look at factoring. And I'm not doing greatest common factor because I have a c. So I'm going to check and see if a times c, will that add or subtract to give me my b? So negative 2 times negative 1 is positive 2. Are there factors of 2 that add to give me 5? Nope. My only options are 1 and 2, and that adds to give me 3, not 5. So factoring will not work for me. I move on to completing the square. If I divide by my a, what happens? 5 divided by negative 2 is 2.5. So or 5 halves, or 2.5, whatever you want to look at that. Definitely fraction or decimal, and so I'm not going to complete the square. I'm going to move on to quadratic formula. Use my formula since I have a, b, and c easily identifiable, and solve from there. Okay, negative 1/2 x squared plus 2x. I only have two terms. And so when I'm looking at that, I need to figure out what's missing. Is my b missing when I would want to use square roots? And no, I have my b. I actually don't have my c, which matches up with this perfectly. So I would choose to factor. I'm going to look at those two terms, see what's the common factor to both, and I'll go ahead and pull out that greatest common factor. Okay, next one. 6x squared minus 4x plus 1 equals 0. Again, I am in standard form. A is 6, b is negative 4, c is 1. So square roots are out because I have both of my linear and quadratic terms. Okay, next up would be factoring. So since I have three terms, I'm going to do a times c. Are there factors of 6 that add to give me 4? Factors of 6 are 1 and 6, that adds to give me 7. 2 and 3, that adds to give me 5. So that's not an option. Option 3, I'd come through and I'd divide by a, so divide by 6, and immediately I see a fraction of negative 4/6, which would be a negative 2/3. I don't want to complete the square with a fraction if I don't have to, and I don't because I have a fourth option, which is quadratic formula. When all else fails, quadratic formula is a great option. Okay, next up, x squared plus 4 equals 0. I only spy one variable term, So I can easily subtract my 4, undo my square, and solve for x that way. This is because I do not have a bx. I don't have a linear term. It's technically 0x, and so I would choose using square roots because that's the format I can spy. Okay, let's try 2x squared plus 3x minus 5 equals 0. I have standard form, A, B, and C. So option 1 is out. Can't use my square roots because I have 2 variable terms. Can I factor? Are there factors of 2 times negative 5 is negative 10? So are there factors of 10 that subtract to give me 3? Factors of 10 that subtract to give me 3, 2 times 5 makes 10. But when I subtract, I'll also be able to get 3. 5 minus 2 is 3. So factoring it is. Don't need to go through the other progressions because I'm going to stop here and factor to find my x-intercepts. Last one. 1/4 x squared minus x minus 2 equals 0. Again, I have all 3 terms, a x squared plus bx plus c equals 0. So square roots is out because I see 2 variable terms, both the x squared and the x. Can I factor? I'd have to do a times c because I have a c term, so this is not an option. A times c, that's going to be 1/4 times 2. A fourth of 2 is a half. Technically, are there factors of a half that subtract to give me 1? And I'm going to tap out right there because I'm dealing with fractions in my brain. So moving on to option number 3, completing the square. If I'm going to complete the square, then I see that I'm actually building 1/4 of a square, and that's a little odd to work with. So I'm going to go ahead and pull out a factor of 1/4. And so when I do that, dividing by a fraction is the same as multiplying by the reciprocal. So I'm really multiplying by 4 over 1. So negative 1 times 4 would give me a negative 4x. And so that coefficient of my linear term in parentheses would be even, nice and neat, no fractions or decimals to mess with. I'd go ahead and complete the square. Just in case you're tempted, thinking forward, would you really want to do quadratic formula if your a is a fourth? And some of you are going to say, sure, I'm going to make it 0.25 because I'm dealing with 25 hundredths and I'm just going to use my decimals and my calculator. And more power to you. If that's what you want to do, then of course that's an option. It's just not the most efficient. It opens up a big can of worms for making calculation error. Okay, so that one we would definitely want to put in complete the square. And this gives you a good overview of several samples. Remember, you will be put to the test to see what methods you want to use and when. Is there one right way and a wrong way to do that? Absolutely not. I mean, you are going to be able to choose what you want, but I will hold you accountable for being able to solve by square roots and factoring, completing the square, and quadratic formula to know that you have a nice full toolbox of options. But which equations you choose to do are, that's completely up to you. You can make it as easy or as challenging as you prefer.